Welcome everybody, and what I hope is that there's something in this for everybody, right? So, I am an engineer, I did study here. When I graduated here in 1968, engineers didn't get paid very much money. They still don't get paid the best money, but they get paid a lot more than I did. And some of my friends, they went off to be chartered accountants, because chartered accountants got paid twice as much as engineers. But I stuck at my engineering. I started in research and development. And one of the things I believe in is following my passions, and I always had a passion for electronics. I had an electrical outfit when I was 8, and I had a radio and TV repair business when I was 13. And all I've done is follow my passions, and I say that to the kids I talk to. If you can find out what your passions are and you can follow them, you might have a chance, right? And as the Blink-182 song says, life is too short to last long, right? So you better make the most of it. So, basically I did my R&D. I gave a talk to the Royal Television Society called TV and Chips. It was a bit of a joke. They were microchips. I gave that to the Royal Television Society, and through that Motorola hired me and gave me a lovely company car. And so one of the other things I say to the kids, I am a fan of the IET. I joined this institution because the year I graduated, a professor here, whose name was Professor Meek, he was the president of the IET, and he says, you should all sign up to this, it'll do you good, right? So, and that's the other thing I want to give you is, you sit exams, you get worried, you have spreadsheets, but life is about people and contact, so it's lovely to be in Liverpool. We started on the company at the end of 1990, so the key thing, and this is how I became Sir in Saxby, had lots of failures in my life, and eventually I got it right. Getting it right is all about failing and picking yourself up. So this is the story of the ARM architecture. For the non-technical of you, ARM is a microprocessor. It was also a company, and Acorn, the company, some of you know the BBC microcomputer, the Acorn Archimedes, a friend of mine called Herman Hauser, who was the CEO of Acorn some while back, he decided that the team there would build a RISC microprocessor. And RISC is reduced instruction set computing. The idea of RISC is it goes faster than CISC. Okay, so they designed this chip called the ARM1, and basically they got a great team of R&D engineers, and they got a great chip, but actually they only made about 50,000 computers a year, and there are also competitors out there like Intel and every major electronics company, Motorola, Zilog, National Semiconductor, all the Japanese companies, Fujitsu, Toshiba, Samsung, they're all building their own chips. So, but Acorn had a chip that was pretty good. But the problem is, of R&D for a little company like Acorn is how do you afford to pay the R&D costs and how do you take the business forward? And actually what was happening is the Acorn Archimedes computer was really losing market share because along with it was coming Apple and the PC, and in reality Acorn's market was people who watch the BBC microcomputer program. So their business wasn't going the right way, and they had an expensive R&D team. There was a guy at Apple called Larry Tesler, who was the chief scientist of Apple, and he liked this ARM architecture, and he wanted to use it for a product called Newton, and Newton came failed handwriting tablet. So again, remember the word failure, but the Newton turned into the iPhone. So in engineering, generally speaking, you have one or two failures, and if you're lucky, you might get some success. And usually, my view of start of a new technology to success, realistically, you're looking at a minimum cycle of 10 years, or more likely 20 years. Okay, so learning how to fail and pick yourself up, I think, is part of good engineering. So what happened is Larry was interested in this technology, and Apple were interested in it, and VLSI Technology, which is another American company, were building these chips for Acorn. And VLSI said to Larry, Acorn are thinking of spinning this technology out into an independent company. And that's where I came along. In the summer of 1990, I got a headhunting phone call saying, Acorn are thinking of spinning this out into a joint venture. Apple are thinking of investing, but unless they have a CEO, it's not going to happen. Can we have a chat? So I had a chat, and I still have the paperwork of the dialogue I had between about August and December of that year about the startup and what the business model would be. And that was my major contribution, I think. So I think that's the other message. I had worked in the semiconductor industry from 1973 till we created ARM at the end of 1990. So I had 20-odd years of experience of the semiconductor industry, I was actually president of an American company, US2, in Silicon Valley. I'd also experience of Japan, in Tokyo, and I was a seasoned, if you like, in inverted commas, semiconductor veteran. And what I'd say to anybody who's thinking of starting a business, good technology is important, but people who understand the market, the competition, the customers, are probably even more important, because actually the world is full of great technology, and but it isn't full of how do you apply that technology to meet a customer need, and I think that's where I was successful. So what happened is we formed a joint venture of the 28th of November 1990. I was the first CEO. I was actually CEO, president, chairman, and everything, because we just had 12 engineers and me, and I did the marketing brochure, I did the PR, I did the travel, I even took my circuit diagrams out in meetings in Japan, because we're a very small, lean and mean startup. And so that was the foundation of ARM. And the first product we created was something called the ARM 6, and the ARM 610. The ARM 610 was used in the Apple Newton. And the first few years, we were honestly struggling to stay alive. We had £1.5 million of seed capital, and that money was due to run out within a year or so. The truth is the 12 founding engineers of Acorn thought that we'd all be bankrupt and Acorn would cast them off. But I persuaded one guy called Jamie Arcott, who was the most senior of the 12 engineers team in Acorn, that we could become the global risk standard. So my vision was, what if we all become the global risk standard? And to everybody's surprise, we did it, okay? And then more things happened. So our first licensee who paid us money was GC Plessy, and then after that came Sharp in Japan, and then after that came Cirrus Logic in America, and Texas Instruments, and so on and so forth. And what happens is the early years, years 1, 2, and 3, they're the ones where you really struggle. And once you start to get successful, momentum kicks in. And we had, by about 1994, 1995, everybody was queuing up wanting to license ARM, and we turned a corner. One of our weaknesses was the conventional chip technology had, for those of you into computers and stuff, they had good code density, and a RISC computer doesn't have good code density. What that means is the size of the program to do a particular job in an CISC technology was smaller than in a RISC technology, and that meant the cost of the RISC memory footprint was more expensive with RISC than CISC. So we invented something called Thumb, and I think that is the most important invention of ARM. It happened, the joke is the thumb fits on the end of the arm, by the way, and it's the 16-bit implementation of a 32-bit ARM which dramatically improves the code density. Another weakness we had major competitors like MIPS in particular, like Intel, like Motorola. We didn't have a very performant ARM chip. We had chips that were good at low power, good at low cost, but we didn't have a high performance, so we teamed up with Digital, and we did something called Strong ARM, which actually was strong and powerful and fast, and that was how we got there. And then Intel, by the way, bought Digital. That was another interesting challenge. And in 1998, we went public. We duly listed on NASDAQ and London. And that was a good idea because American markets at the time valued technology more than London markets. And then in 1998, on paper, I was wealthy. We actually created 200 millionaires in the year we went public, because I'm a great believer in share options. All employees had share options. But I do believe, again, in life, there's like a boss, there's like everybody in the team should make a contribution, and just because you're the boss doesn't mean you're any good. You might be good at something, but there'll be other people that are good at other things, and it's about the team. So I believe that share options in a startup are a very good idea, because startups, you pay less salary, you work longer hours, you do more work. There's got to be some upside somewhere if you make it successful. This journey, it took about 8 years to go public. It was like, will it ever happen? Will we ever go public? Will we ever make money? And that's another risk of startups, if you like. And something else that also helped us, we were in a European collaborative project, which is called the Open Microprocessor Systems Initiative, that I actually chaired. And we were getting in years 2, 3, and 4 about £400,000 a year from Europe. And without that project, we probably would have gone bankrupt, right? So this is another interesting issue we have at the moment in this world. I'm not black and white about any politics, but what the European collaboration gave us, as well as money, was we established an on-chip standard bus called AMBER within this European project. So I am a fan of European R&D projects. And then what happened is, So after going public in '98, I stayed CEO immediately after that. I'm a great believer in succession planning, and I stopped being CEO at 54. Did that a year early. That's when Warren took over. And I said I want to stop being chairman at the age of 60, and I think I stopped doing that at the age of 61. So I do believe in planning. So Warren took over as CEO. He is now the CEO of Rolls-Royce. Warren is somebody I hired, and we're still good friends. I retired from Warren in October 2007. And Simon Segars is the current CEO of Arm. He's somebody I employed as about employee number 16. And you probably noticed in September of 2016, SoftBank acquired Arm for about £23 billion, I think, which is not bad, you know, for a 1.5 million seed investment. And Simon is now on the main board of SoftBank. So in the life of Arm, private company, money from America, money from Japan. We've got Japanese investor as well in about 1993. It's always been a global company, and it just happens to be owned by some Japanese this week. Anything can happen in the future. And that's I retired from Arm in 2007, but you can click on that and see the milestones and the history of Arm going forwards. So, how did it happen? I am a very big believer in SWOT analysis. Strengths, weaknesses, opportunities, and threats. I think you can apply this to anything, by the way. Whatever it is you want to do. If you do a SWOT analysis, I think it's a very good start, and it's a tool I learned from Motorola. And I got this team of 12 founding engineers to do the SWOT analysis. So I told them what SWOT was. I didn't actually contribute to this analysis at all, and you see they did it on the 18th of December 1990. So the 12 founding team, who had virtually no commercial experience, they're all engineers, came with this analysis. And what they said is the ARM architecture is low power, that means it's good on batteries, it's low cost, it's cheap actually, it's simple and it's small. And this 12-man founding team was flexible, responsive, dynamic, successful, enthusiastic, and they had extensive systems expertise, because basically they had designed the Acorn Archimedes computer in chips, so they could do the chip layout, but they could also do the software. They did the operating system called RISC-OS, and in this 12-person team, they happen to be all men, but you know, could be different today. They had a broad experience, and that was pretty good. Weaknesses: zero market share, zero market profile, zero revenue, zero marketing expertise, limited resources. If you wanted to program an ARM chip, you need an Acorn Archimedes computer, and we want to be the global standard, and there's only about 100,000 Acorn computers out there. That's not going to work, is it? Didn't know much about characterization, test, and manufacturing, and there was a reliance on one foundry manufacturing. So they had one partner, VLSI technology, and nobody else had made an ARM chip. What did we see as the opportunities? We said portables. Portables turned out to be digital mobile phones, but at the time, digital mobile phones hadn't arrived, they were still analog at that time, but we said portables. The big market for microcomputers is embedded control. That means everything, in your printer, in your camera, all the bits of stuff in your electronics product, and that was the volume market. Automotive, cars, radiation hard, that again, a few of those. And we said again, places in partnership, Japan and the Far East, this European project OMI, silicon manufacturers, silicon users, silicon distributors, Apple, get a bit of money from them because they were the only partner who had any money, because Acorn didn't really have a lot of money, although we did get a bit out of them, and some consultancy. Threats, big rivals. Okay, that was every semiconductor company on the planet. Texas Instruments, Intel, National Semiconductor, LSI Logic, Toshiba, 150 competitors, all with hundreds of millions of dollars and people to kill us. We're going to be the world's global standard and an intellectual property company, and we don't have any patents. Earlier, that's not so good. Small team relying on individuals. We're working very long hours. Existing commitments. So for the foundation of the company, we had to do this chip for Acorn, which is a floating point accelerator that used half the engineering resource of the company, and only 500 of those chips were ever sold, right? So that wasn't particularly good. And we had a single customer at present, that was Apple, and we had no control over our income. So that was the foundation SWOT that these engineers did. So, this is where I come along with my experience. So, with all those weaknesses, the only way we're going to succeed is if we become the global standard, really. And I actually said we will be the global risk standard, with the words I used. Everybody said I was mad, I probably am, but anyway, we did it. And everybody says, what's he talking about? How can we do that? We've only got 5 shillings and 6pence, all those companies. We'll be bankrupt. But Jamie said, yeah, I think we might do it. And then we also said, we need to create a partnership business model in order to succeed. We needed to create a community, to have standard architecture to make this work. We turn our enemies into our friends. We needed to develop sales and marketing skills of the founding engineers. So in my previous job, which was US2, this was a startup which was doing direct write on wafer e-beam stuff. And the bad news about US2, the technology didn't work, and I had to fire most of the people there to try and get to break even. I was doing that, and I thought, well, if we start lean and mean and grow the business as the income comes in, that's better than having to fire everybody. So with this 12 founding team, I put Jamie in charge of sales. He was the head of VLSI. I put Mike, who wore a purple tie, I put him in charge of marketing, and I put Tudor in charge of engineering, and we just did it, basically. Started building a patent portfolio. We got some external patent agents, and we got that building. And then software design tools on a PC, we did that. And then the key benefit of ARM, which is where the technology was better than anything on the planet. We had the best MIPS per watt, which is performance over power consumption. And we had the best MIPS per dollar, which is performance over cost. And that's how we could win. And everybody's saying, you're going to get this in mobile phones. Mobile phones never need a RISC architecture. Fortunately, they were wrong, we were right. And then the other key thing is we'll enable this chip to be embedded within a system chip, and we'll turn it into a standard. And then we identified key end users. So the people we got the money from were the semiconductor companies like Plessey, VLSI, Sharp, Texas Instruments, Samsung, LSI, Logic. But we understood what the needs of their end customers were in order to make sure the architecture fitted with those needs. So in fact, with Apple, which was doing this Newton, the chip supplier was Plessey and VLSI. Sharp, our first Japanese licensee, the big design win was the Nintendo Game Boy Advance. Nokia, which was the first really successful product, it was the Nokia 6310. And that's why we invented the thumb architecture. Samsung, I had a meeting with Samsung in about 1992. A guy called Hyun Lee Rowe. And he is a really great guy, Dr. Hyun Lee Rowe. And we talked about the benefit of embedding RISC processors in everything that Samsung made. And he got the idea, and they did it. And it's been hugely successful for Samsung. If you look at where Samsung is technologically today, that was almost the foundation of their success. Similarly with Nokia, the Nokia 6310 at the time overtook Ericsson and Motorola. So win, 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 win is the business idea. And then LSI Logic, we got into disk drives and so on. So from the starting of ARM, we also thought about community. Who's going to add value to this architecture? So we had silicon partners, these are the people who built the chips. We had design support partners who could give consulting design advice. Software partners, people like Microsoft, people like real-time operating system companies. Training partners, systems partners, standards bodies and so on. Again, RMI is part of that. And basically we turned an architecture which had one chip supplier, VLSI Technology, one customer, Acorn, and no software really, into the global standard. So at today's date, I'd like to thank you all, because you've all got lots of ARM products in your pocket. It doesn't help me anymore because I'm retired and I don't have any shares, but every time you buy a chip with ARM in it, ARM gets a few cents of royalty. So the business model was about licensing the technology for a few £1 million, and every time somebody uses a chip, a few cents, maybe 10 or 20 cents. And so the good news is, the total number of ARM chips sold on the planet today is more than 100 billion. So the ARM architecture is by far the most popular architecture on the planet, overtaking Intel and everything else. And we kind of did it, right? And what I say is, since I graduated here, and I struggle with my exams, and I'm still alive, if I can do it, anybody can do it, really. But what I would say is, you've got to have ambition. You've got to think beyond the possible and back up to reality. And there's nobody who doesn't use ARM today, including Intel. So what are the lessons? And this is where technologists in particular, I think, struggle a bit. Study existing markets and understand the leading teething customers, their needs, who your competition is, and learning points. I'm very heavily involved in quite a few startups today. And it's quite normal for startups to not pay enough attention to the competition, be too arrogant about their own technical advantages, and not think it through properly. Another reason why I believe ARM was successful, and this is part of my international experience, I had the board, particularly Acorn, saying, hire more engineers in the UK, hire more engineers in the UK. I said, no, I hired a guy called Tim O'Donnell in Silicon Valley who had worked for me before at US2. He actually insisted on me hiring him. He wouldn't leave my swimming pool in my hotel in the Sheraton Silicon Valley until I'd offered him a job. And I was with Tim in Hawaii just the other day for Halloween in Hawaii, which is a fun place to go for Halloween, by the way. Probably the best place to go for Halloween. I do recommend it. Street parties there are pretty good. And Tim was an applications engineer, but what I said to him was it takes as long to develop the customer as it takes to develop the technology. We need somebody in Silicon Valley. So we hired Tim as employee number 18 when they were telling me to hire lots of engineers. We hired Takeo Ishikawa, which kind of means Rocky River in Japanese, as about employee number 33 in Tokyo. We hired a guy called Sam Kim in Korea. We hired a guy called Jun Tan in China, and so on. So these people, again, it's about cultural stuff, it's about language, and the classic British thing is fly in, fly out. As soon as you've left, it's all changed. So you need local eyes and ears on the ground, and then these people become company presidents later. So Arm, I think, has over 1,000 engineers in Bangalore now. So I really believe very strongly that unless you're global, unless you're globally successful, forget it. And if you look at where China is today, or India is today, versus where they were when we started on, that momentum is gathering more and more pace, and any startup anywhere can do good stuff, provided they've got the right contacts. And then the other thing is customer pull is more important than technology push. If you can solve an explicit need of a customer, you might get a purchase order. And the example I give of this is, supposing I wanted to sell you a parachute, right? Would anybody like to buy a parachute? I guess you're not too interested in parachute. Can you imagine if you were falling out of a plane and I'm coming by and I can clip a parachute on your back and I say, how much will you give me for that parachute? So that is the explicit need of the customer. If you understand that, you might get some successful business. And technology only has real value when you solve a real problem. So the parachute saves your life, right? But so it's understanding the customer's problems and doing a better job to solve them than the incumbent suppliers and so on. And then one of the things about me is I try to be brutally honest. It causes me a lot of trouble sometimes. But brutal honesty is about what do I honestly think. It doesn't mean I'm right, it just means these are my opinions. Now challenge them. And within the team we had a culture of challenging each other, okay? So we've got this ability of challenging ourselves and going through, but be honest, be realistic, be down to earth, be pragmatic. And the best person to challenge me, of course, is my wife. We get on very well. So partners are also very, very helpful. Firm feet on the ground in your partner is another good idea. And then the other thing is, as a startup, you need the best finance people. You need the best lawyers, but you can't afford them. But what you can do, you can get them part-time. And so the first finance director of Arm was a guy called Peng Wong, who was from Malaysia originally. He had been my finance director at ES2, and I got him doing the finance work for me part-time. Then when we could afford him, we hired him. The founding lawyer of Arm is a guy called David McKay. He was Acorn's lawyer, and the patent agents and so on. So you are, again in the team, you are as weak as the weakest link, and it's the same in the football team. If the goalkeeper's no good, you've got a problem, right? So you need every position covered. And then the other thing is, if the team is really good, and I think we did this with Arm, the team, if say there's 12 people in the team, you should get an output greater than 12 if the team is working well, right? So this is called synergy. So I believe in a really good team, that's what you want to do. Teams that are not so good, you've got 12 people and you get an output of 4 if you're lucky, right? And a lot of nonsense is talk practice. That's what most of real life does. And the larger the company, the harder it is to be successful. So a small team is easier than a large team. The bigger it gets, the more people involved, the more communication problems you have. And then the other thing is you need different people at different times. So I'm very happily retired from one, but the people there are very good. And so it's like football players at a certain age. You want to change, you want to do something else. So be honest about rotating people, changing people, and so on and so forth. And then the other thing which I really do believe in, this is why I'm doing music now, and to see how impossible it is, think beyond the possible and back up to reality. Okay, you're going to get a song later. And you can tell me the honest truth, by the way. If you don't like the song, you can tell me I won't be hurt. Okay, some observations. People often focus too much on technology push rather than customer pull. And that's the classic engineering mistake.
The first purchase orders and setting them up is the most important thing to do. If a customer pays for something and you make some margin out of it, you've probably got the right answers and the right solution. If you haven't got any customers, start again. Purchase orders are the most important thing. And to succeed, you have to be the world's best at something. It doesn't mean you're the world's best at everything, but in our case it was mixed for what, mixed for dollar, and an embedded core. Unless you're focused to be the world's best at something, I'd say don't bother. Life's too short. Team is as weak as the weakest link. This is the other thing that's hard as a boss. When you promote somebody, you believe in them, and they're not delivering, and it's hard to be realistic about firing them or changing them. But be as brutally honest as you can be. And then I also believe in every board decision of ARM was unanimous. We would debate everything. We'd have violent arguments. Consultants would come in and say, this is the rudest board meeting we've ever been to. That's because we were being honest. And then the other thing about venture capital money is times of money in venture capital. Most venture capitalists, they want to see a return on investment in 4 or 5 years' time. But in a hardware-related technology business, to get real value, it takes a lot longer. That's one of their problems. So if you can get angel investment that's got a longer-term horizon, you probably get a better chance. And then understand your total ecosystem. So just an example of that. So we're selling chips to Texas Instruments. Nokia are using those chips in their phones. Vodafone is the operator. There's services and applications that go on top of that. See the whole picture, because the devil is in the detail, and if you're just looking at a little piece, something will happen that you didn't expect. That's what I mean about the whole ecosystem. And then this is another message for today that I've realised. So in business, call me right back, get the purchase order overnight. The pace of business and making decisions is very quick, and it's global, and it's real-time, 24/7. World of academia, it's a bit different because you're working on a long-term project, you've got more time, you're doing your project, it takes several years maybe, it can run at a slower pace until it's going to the critical time where you've got to get your PhD. And the world of politics, something I don't understand, but we decided to do something and it still looks like we don't know what we're doing in a political one. So what I've realised is, it's not that business is right or politics is right or academia is right. What I say is just recognise the differences and try and be honest about where they work together, and they run at different speeds. And then keep it simple and learn by doing, and beware the drug of funding. What I mean by that is, you just keep getting the money from Brussels to do the project, and actually you're not doing anything really. It's the drug of funding. Okay, so where is ARM today? So I retired from ARM in 2007, but more than 100 billion chips shipped. The most popular microprocessor architecture on the planet. ARM has recently signed a license agreement with the Chinese to do the world's fastest supercomputer. So that's pretty nice. I didn't expect that to happen, really. More than 5 billion, just about everybody's connected with ARM chips. People need to be woken up by their Apple alarm clock or get their email or their WhatsApp message. So we have seriously impacted the world. In some cases, one of the things that made me feel really good, I was in Morocco in a very poor village, and people were using their mobile phones with ARM chips for commerce and improving the quality of their lives. Again, things like controlling water. So there are many nice applications of ARM technology, and I'm actually going to a talk that ARM is hosting with UNESCO at St. James's Palace on Tuesday, trying to use technology to improve the world. Always on, always connected. Storage in the cloud are very important today, and it worries me that nobody thinks about that. Internet of Things is the new buzzword. It basically means everything's connected to everything, but it's okay until the security goes wrong and somebody steals your car and the cloud collapses and you don't know where you are. But there's an opportunity there. And then the other thing I'm quite personally pleased about is the Raspberry Pi, which was another Cambridge startup, and the Microbit are getting programmable microcomputers into the kids' hands, and I've got a couple of Raspberry Pis because I like playing in my lab. So that's where ARM is today. Now, looking to the future, and this is where I am personally, if I look at the startups that I'm involved in, they're not doing what ARM is doing, they're doing some new stuff. So one of the things that matter for the world of tomorrow, energy efficiency, right? We waste so much energy, whether it's air conditioning or heating or lighting or whatever, that's a big area. Security, I don't think we've even started to think about the reality of security. I think everybody takes it all for granted, but potentially it's a nightmare. It's also an opportunity if you've got stuff in line with hardware, software, clouds. Healthcare, another big area. Servers, right? The amount of these servers that serve Google and Facebook, they actually run them next to power stations because they take so much power. Connectivity, robotics and artificial intelligence, cloud and machine learning, and the Internet of Things. So the other good news is, for kids who are graduating today, there's even more great stuff to do, because when healthcare and medicine cross, so the world is just starting in terms of this technology, and there's lots of great stuff going on. So Sensible City, I don't know if you know about it, but I visited Sensible City the other day. It's just down the road. The idea is it's about sensors and connecting things and doing great stuff and startups. It's on your doorstep in Liverpool. It's fantastic. I personally put some money into the Royal Academy of Engineering's enterprise. So the Academy of Engineering has been good at creating PhDs and professors and all the rest of it, but we haven't been so good at creating jobs. The good news is we've got about 80 startups and we mentor, and again, if you're thinking of a startup, you can get free help and you can go on hot desk and what have you. And then the other thing, and this is the kind of joke, and it's because it's Christmas, and this is my new hobby. I have many new hobbies. Basically what happened is I was the after-dinner speaker at University College London, 35th gala dinner of the computer science department, and I thought the last thing the kids need is an after-dinner speech. So 2.5 years ago, there's a guy called Carrie who plays guitar from Ghana, and there's a girl called Nina from Brazil, and I went over and said, will you help me out of a jam? I'm going to try and give my speech to music, and we turned the evening into Blues Brothers. So then Carrie said, why don't you write some songs and come into the studio? I've got Yumi, who's my piano teacher here, so I started my piano lessons with Yumi a couple of years ago. And what I'm going to do, I gave a lecture last week at the university, and somebody said, can I get your song somewhere? So in the last week, I've put some songs up in Bandcamp. So if you want to download these songs, they're all up there. It's robinandfriends.bandcamp.com, and you can rate me and do it. And what I'm going to do now is, as it's Christmas, and as I love Liverpool, the song I've decided for tonight is Che Che Liverpool. Okay, so Che Che Koule is a Ghanaian folk song, which is like for the kids. It's like hide and seek, up and down, Che Che Koule. So that's Carrie. And then it's Che Che Koule meets Liverpool. And what you'll get here is my story. You have to listen carefully for the words. I met my wife here. So
global influence from local passion. Scouse wit, true grit, unique fashion. Liverpool, best city in the world for me. Mercy flows way beyond the sea. Liverpool, so cool. Red electronics made friends for life. Diverse people met Patty, my wife. Beatles attracted me to this place. Bombed out, yeah, total disgrace. Investment post-war, the key to an open door. Lived in Roscoe Hall with central heating to welcome those I'm greeting. Bachelor of Engineering, apt labeling, but friendships most enabling. We enthrall, lots of love and hope for all. Music of all genres every night. Plastic glasses to avoid the fight. Bass guitarist with a scar in the Triton bar. The Who played for us. Broke guitar. Duke Ellington too. Peter Green's blues, such a coup. Liverpool, my spiritual home. A sanctuary when I'm all alone. Liverpool, so cool. Woo-hoo. Woo-hoo. There flows the Mersey. My best city. So cool. Liverpool.
songs, one of them has lines like age is just a number, don't let it get you down. So you can tell my age doesn't get me down at all. In fact, I've got more freedom at my age to do more what I want. So thank you for listening. We're all different. We've all got skill. Every human is really important. You just got to work out what it is you want to do. And if you can, you got a chance. And I wish you all lots of luck. Thank you.
Very inspiring lecture, Sir Robin. We're also sharing that your song. It probably could be a theme song for the electrical engineering department.